discuss about the what is mensuration. So, mensuration is a division of mathematics that study geometrical figure calculation and its parameters such as area, length, volume, later surface area and the surface area, and etc. So now let's see the area and the parameter of some 2D shapes. So here we are going to see the area of the and the perimeter of the rectangle. That will be the perimeter of the triangle is sum of all sides, that will be side plus side plus side, and the area is 1 by 2 into breadth into height. Now let's see the area and the perimeter of the parallelogram. So the area of the parallelogram will be breadth into height, and the perimeter is 2 into side plus side. That will be the side plus side will be the opposite parallel sides of the parallelogram. And the area and the perimeter of the rhombus is, so now let's see the area. So the area of the rhombus is 1 by 2 into diagonal 1 into diagonal 2, and the perimeter of the rhombus is 4 into side. So now let's see the area of the trapezium. So the area of the trapezium is 1 by 2 into sum of parallel side into altitude, that means height of the trapezium. Now let's see the area of the quadrilateral. So the area of the quadrilateral is 1 by 2 into one of its diagonal and the sum of offhand sides corresponding to the diagonal, that will be h1 plus h2. Here we also see the h1 and the h2 in the figure as well. Now let's see the Heron's formula. Now Heron's formula is always applied on a triangle when we know only the sides of the triangle. That assume that A, B and C. So here in the picture we also see the boy who is telling about the Heron's formula to another boy, and first he is telling about the sine perimeter, that is A plus B plus C divided by 2. Now by using the Heron's formula and the sine perimeter, the area of the triangle we can find by the formula, that is under root sine perimeter into sine perimeter minus A into sine perimeter minus B into sine perimeter minus C. So now let's see the Heron's formula discovery. So this formula was discovered by Hero of Alexandria, who was a Greek mathematician in 10 to 7 AD, that is Anno Domini. Now let's see the volume, total surface area and the area of 4 walls of some figures. So here we are going to see the volume TSA and the area of 4 walls of cube. So the volume of the cube is A cube and the total surface area is C into A square, and the area of 4 walls is 4 into A square. So now let's see an example. So let the side of the cube will be 44 centimeters. So by putting the area of the volume, we can find the volume of the cube, that is 44 into 44 into 44. That will be 85184 centimeter cube. Now let's see the another one, that is area of the 4 walls. So by putting the area of the 4 walls formula, that is 4 into A square. Now by putting the formula we got 7744 centimeter square. Now let's see the total surface area of the cube. By putting the formula of the total surface area we got the answer, that is 11616 centimeter square. So now let's see the volume, total surface in the area of the 4 walls of cuboid. So the volume of the cuboid is L into B into height, and the total surface area is 2 into L into B plus B into height, and the plus height into length. Now let's see the area of the 4 walls, that is 2 into L plus B into height. Now let's see the example. So let the length of the cuboid is 8.5 centimeter and the breadth 10.5 centimeter and the height 4.5 centimeter. So by putting the formula, we got the volume of the cuboid is 89.50 centimeter cube, and the total surface area from the cube will be 349.5 centimeter square after putting the TSE formula. Now let's see the area of the four walls of the cube. So by putting the formula of the area of four walls, we got the answer that is 171 centimeter square. So now let's see the cylinder volume, total surface area, cylinder surface area. So here is not a four walls area because the cylinder does not have any walls. He is in a shape of the cylinder in a circle. So here we calculate the cylinder surface area. So the volume of the cylinder is pi I square h and the total surface area is 2 into pi into r plus h. And the cylindrical surface area of the cylinder is 2 into pi into r into h. So now let's take an example. So let the cylinder radius will be 1.5 centimeter and the height is equal to 4 centimeter. So the volume of the cylinder by putting the area, so now let's see the volume, total surface area and the cylindrical surface area of the cylinder. But before discussing about the formulas, we have a question. Why there is not an area of the four walls? Why cylindrical surface area? So the answer of this question is simple. This is why because there is not any four walls. There is a circle bigger surface area of the cylinder. So here we calculate the cylindrical surface area, not the area of the four walls. So now let's move to our formula. So the formula of the volume of the cylinder is pi into r square into h. Now let's see the TSE, that is total surface area of the cylinder, that is 2 into pi into r plus h. Now let's see the cylindrical surface area, that is 2 into pi into r into h. So now here we can take an example. So let the cylinder radius will be 1.5 centimeter and the height is 4 centimeter. So now let's discuss about the volume. So the volume will be pi r square into h. So after putting the volume formula, we got the answer, that is 28.27 centimeter cube. So now let's find the total surface area of the cylinder, that is 2 pi r into r plus h. So after putting this formula, we got the answer, that is 51.85 centimeter square. So now let's see the cylindrical surface area. So the cylindrical surface area formula is 2 into pi into r into h. So after putting this formula, we got the answer, that is 37.71 centimeter square. Now let's see the volume, lateral surface area and the total surface area of the cone. So now here we got a new term, that is lateral surface area. So we will discuss about this in the next slide. So quickly discuss about first, that is volume. So the volume of the cube is 1 by 3 into pi r square h, and the lateral surface area, that is pi into r into lateral side, and total surface area is 2 into pi into r into r l lateral side plus radius. So now here we are going to discuss about the lateral side. So the slanted side of the cone is known as lateral side. So here is the question arises, how we can find the lateral side. So as we all know that if r is radius of the base of the cone and the height of the cone and the lateral surface length of the cone, will we make a right triangle. So by using the Pythagoras theorem, we can find the lateral side, that will be L is equal to under root r square plus h square. So now let's see an example. So let the cone radius will be 1 and the height will be 3 centimeter. So the volume of the cone after putting the formula 1 by 3 into pi into r square into h, that will be 3.14 centimeters cube. And now the lateral surface area will be 9.42 centimeter square after putting the formula, that is pi into r into lateral side. So now let's see the total surface area. So after putting the formula we got the answer, that is 25.14 centimeter square, that is 2 into pi into r into l plus r. So now here is a question round. So the first question is, what is the formula to find the total surface area of the cube? The answer will be 6 into a square. Now let's see the second question. In what condition we can use Heron's formula? So we can use Heron's formula when we know only the length of the triangle but not its height. Now let's see the third question. What is the formula of the lateral side of the cone? So the answer will be L square is equal to R square plus H square. By using the Pythagoras theorem, L will be the under root H square plus R square. Now let's see the fourth question. To the lateral side we use the concept of the which theorem? So the answer will. Thank you for watching my video and giving your precious time. Thank you so much.